drying or lipophilicization is a high-tech preservation method that look in food texture, nutrient, and flavor by passing the liquid phase entirely through a process called sublimation. First, the food is fresh frozen at extreme temperature, turning at all water content into solid ice. Next, it is replaced in vacuum chamber when slight warmth is applied, causing the ice to turn directly into water vapor without even melting into liquid. This is because the food physical texture never melting into a liquid. The result incredibly lightweight, nutrient dense product that retain nearly around 100% of its original vitamin and can sit on a shelf for up to 25 years. Contain about 18 until 18.5 water, making it relatively heavy and high feasibility with a short shelf life. After freeze drying, nearly all the water is removed, reducing the moisture content to less than 5%, while preservation must have a fruit neutral color, flavor, and nutrients. The mango, because like in wake with a crisp, crunchy texture and can store for months or even years in a packaging without refrigeration. Before freezing drying, roselle is fresh, moist and rich in water, making it prone to spoilage. After freeze drying,
within the category of advanced drying technologies, variety of several methods are utilized by modern industry to save present high-value agro-products and biochemicals. As example, today I will focus on one of the most principal alternative available freezing drying to emphasize how to this technology drying product with using distilled heat. The secret lies in precisely is phase to change the process shown in this video, which is a divide into the three critical engineering stage. The first stage is freezing phase. Here the liquid agro product or formula filled inside the via in variable color down into the water molecule inside the completely turned into the solid ice crystal. This look the chemical structure scheduled in place. Next, the video shows the second stage, a primary drying, which is derived by simulation the chamber pressure to dramatically lower into the vacuum and a controlled amount of the heat energy through the server. Because the system dropped the pressure below the triple point of water, this ice freed from melting into the liquid instead of the ice crystal swirling, meaning that transfer directly from solid ice into the water vapor. The final stage is secondary drying, which involves dispersion. At this point, any remaining moisture bound in chemical to the product is divide off the safely rising the temperature under the deep vacuum. The vacuum continually draw the vapor through the exactly cold condenser turn back into the ice looking in the way. The key scientific principle behind this technology is to operate entirely under the triple point of the water. By skipping the liquid phase completely, the product does not sink, boil or lose in structure in natural integrity. In conclusion, freezing drying is a phenomenal example of advanced drying, offering unmatched quality preservation from highly sensitivity, corrology and agro product. For next, my teammate will explain how this aspect.
Hello everyone, my name is Sanasenda. So today there are three applications of freezing drying technology in different agro product industry, which are fruit and vegetable processing, is preserved seasonal fruits like berries, mango and apples, and vegetable like peas and corn. And second, dairy and beverage industry, used to produce instant coffee, tea extract, and powder dairy products like yogurt drops and specialized milk powder. And the last, meat and seafood processing applied to cook meats, poultry, and seafood components used in ready-to-eat meals, military ration, and camping food. Okay, for example, the strawberry must have a preparation and washing. Freshly harvested strawberries undergo rigorous washing, de-streaming, and sorting to eliminate defective fruits. And the second, circulation IQF freezing. The strawberry enter an individual quick freezing IQF channel, rapidly freezing them to solid ice. And the three, tray loading and chamber charging. The frozen strawberry are evenly distributed across large metallic processing trays and loaded into the massive cylindrical chamber of the freeze dryer. And the last, depulization. The chamber is sealed, vacuum is drawn. A benefit freeze drying technology is freeze drying preserve the fruits like strawberries in nutrient, color, flavor, and shape better than many other drying methods. But the limitation is the freeze drying equipment is expensive and require high operation costs. But the efficiency is freeze drying efficiently remove water, resulting in a long shelf life while maintaining high product quality. There are two brand name or manufacturer of freeze drying technology, which is Labo LVD6 and Chemolo Freeze Drying Co Ltd. So there are three differences between Labo and Chemolo. From aspect features, Labo compact laboratory scale design with limited capacity, around 6 until 7 kg per batch, and manual tray handling. Meanwhile, Chemolo, giant factory scale industrial design with massive capacity, around 50 kg until 5,000 plus kg, using an automatic trolley rail system. From aspect efficiency, Labo is optimized for low utility costs in small space using a standard single-phase electric heating system. Meanwhile, Chemolo is optimized for factory energy saving of up to 30% using radiant heating and compressor heat reclamation. And the third, functionality from Labo is manually controlled via a flexible local touch screen electrode for research and development purpose. Meanwhile, for Chemolo, fully automatically controlled via an industrial PLC system with a large-scale data management for factory. So, as shown in the video above, is demonstrate the real-world application used by the Chemolo industry, which is the freezer drying technology.
Assalamualaikum and good day everyone. My name is Izzat Hasmi bin Muhammad Saidin. My number metric is F25A1883, and today I would like to talk about variation in the market of advanced drying technique, especially in freezing dryer. When exploring the freeze drying market, we see a massive divergence in technology based on scale. At the entry level, we have small scale and benchtop units, costing between $2,000 to $5,000. These are perfect for boutique shops or small labs. However, there's an efficiency threat. While the upfront capital cost is minimal, they carry the highest operational cost per kilogram because their batches are limited to just a few. The total cycle time is 20 to 45 hours per batch. These machines use automated generalized presets. They lack hyper-precise heating controls, and to prevent from any caution, they extending the drying phases to ensure the center of thick foods is completely dry. As comparison to small-scale system, we look at industrial scale system. This require a major capital investment, anywhere from $200,000 to over $2 million. They demand heavy-duty 3-phase power and advanced glycol chilling infrastructure. But this is where efficiency peaks. By processing tons of product per batch, they achieve massive economies of scale, dropping the final cost per kilogram to its absolute lowest. The total cycle time is 8 to 24 hours per batch. Why is it much faster? Industrial systems use massive engineering advantages to cheat the clock. They use hyper-precise multi-zone shelf heating, stronger specialized vacuum system, and advanced thermodynamics tailored precisely to a single product. To combat the high energy demands inherent to sublimation, The modern market is prioritizing sustainability. The latest industrial systems are integrating digital twins to virtually optimize drying cycles. Alongside microwave and ultrasound innovation existed that cut overall drying times by up to 70%. Ultimately, selecting the right machine requires balancing your initial capital budget against long-term production volume. That's all from me. Thank you.